we were to talk about chemistry in terms of a science and sort of define chemistry as something than just the study of everything, if we were to define what chemistry is, we would say that chemistry is the study of matter or stuff like food, your clothing, air. It's the study of matter and the changes that it undergoes when it interacts with other matter. So matter, that's sort of a fancy term that we use for stuff. We can sort of classify that or define it a little more by saying that matter is anything that has mass, has weight. You're going to do a lab on weights later on in the semester. Matter is anything that has mass and takes up space. And if we were to even further classify things that are matter, we could say that matter is made up of two components. They are made up, or two categories. Those categories are compounds and elements. Now we're going to further subdivide those classifications, compounds and elements, in chapter 3. But in this chapter, we're just going to take a very, very cursory look at compounds and specifically elements. Here is one of my favorite slides. It's one of my favorite slides because it has on it this beautiful table that chemists use to classify elements and say something about their properties. You probably know it more commonly as the periodic table. Now in chapter 3, and particularly in chapter 4, we're going to talk more about the periodic table and how it's classified and what is in each little box on the periodic table. What you need to know now for this chapter and for the quiz on it is that elements are what are on the periodic table. So each little square, each little box is the home for an element. And an element is something that cannot be broken down into simpler parts without losing the properties of that substance. So if I was to take a sample of helium and break it down, the smallest part of helium that I could get, and it would still be helium, would be an element. And that smallest identifiable part of an element is called an atom. And all atoms of an element are identical. So for example, all of the atoms for helium are identical, but different than all of the atoms that make up lithium or the atoms that make up beryllium. So elements, they cannot be broken down into simpler parts without them losing their unique properties. The smallest identifiable part of an element is called an atom. And we will talk more about the particles that make up an atom, but atoms are the smallest identifiable part of an element. So the majority of the elements that are in the periodic table exist as individual atoms. So for example, mercury. Hopefully you don't have a mercury spill close by, but mercury is made up of individual mercury atoms. Most elements are made up of individual atoms. There are some, however, that like to buck the trend. We will define those more in chapter 4, but there are some elements that exist naturally or are more stable if they are diatomic. Dia meaning two, atomic having two atoms bound together. So for example, chlorine. Chlorine is one of those elements that likes to be diatomic. Dia again meaning two. And we show that two with the little subscript. So there are a few elements that like to exist as diatomic molecules, molecules meaning more than one atom together. The elements that like to be diatomic, we'll talk about later. Just now know that most elements in their natural, most stable state like to exist as individual atoms, but there are a few that like to buck the trend and be diatomic. Speaking of molecules, when we talked about diatomic molecules, those were two atoms coming together to form a molecule. A lot of this course is going to be talking about atoms and their properties and what happens when they combine to form larger, more complex substances called molecules. So I have two figures right here, sort of ball and stick figures of two molecules. And so the take-home message from this slide, aside from saying that atoms combine to form molecules, is that when atoms combine to make a molecule, they do that in whole number ratios. What that means is that you don't see half an atom or 3/4 of an atom in a molecule. For example, in carbon dioxide, for every one carbon atom, we have 2 oxygen atoms. For a water molecule, for every 1 oxygen atom, we have 2 hydrogen atoms. And so how we show that in terms of a chemical formula, we'll talk about later, numbers and types of atoms. Just know for right now that atoms, when they get together and have a party and make more complex substances, those substances are called molecules. One last slide for chapter 1. Your book mentions the difference between scientific theory and scientific laws. Now, this part of the course would be more, I think, important if we were actually gathering in lab and doing actual hands-on experiments. Unfortunately, we won't be doing that this semester, but it's still important for you to know the difference between a theory and a law and something about the scientific process. And I admit, I'm guilty in using theories and laws synonymously, but they really do mean something different. A theory explains why something happens, where a law says what will happen. So, for example, if I was to, the law that an apple falls from the tree at gravity, that predicts what will happen. I predict that this apple falls from the tree. There's a law. But why does that happen? Why does that apple fall from the tree? Well, that talks to the theory or explaining why something happens. To take a chemistry example, we already said that atoms, when they combine to form molecules that are in simple whole number ratios. That would be an example of a law. I have predicted what will happen. Atoms combine to form molecules in simple whole number ratios. But why does that happen? The atomic theory, what explains why that is the case, that would be called a theory. So, first point from this slide, know the difference between a law, which predicts what will happen, and a theory, which explains the why of why it happens. And you should also know the 3 parts of the scientific process, which you're probably familiar with from another physical science class. When a scientist makes some sort of observation and then forms a hypothesis or an educated guess as to why that observation happened, and you do lots and lots of experiments to support your hypothesis. And many times you have to refine your hypothesis and refine your experiment. So many times this step of hypothesis and experiments gets repeated over and over again. That's what you guys would be doing in lab if we were in a normal semester. For right now, you're just going to have to know the 3 parts of the scientific process that chemists use, biologists use, any scientist uses: observation, hypothesis, and experiments.